Question number 5. Y equal sine half a theta. This is theta, and we need half a sine theta. First of all, I'd like to draw sine theta. Sine theta is going to be like this. So this is the sine theta curve. When it becomes half a sine theta, this is going to be this kind of curve. This is y equal half a sine theta. You can see in a sine theta graph, this is 90. This is plus 1. But the same plus 1, now you will get at 180. There is a delay, 2-time delay to get that plus 1. In other way to get this 90, you want to put 180. Sine half a times 180, and this is cancelled out, sine 90. It means the one you will get at not 90, 180. Now they ask what is the period. Period means the distance between two similar points, or so this is continuing like this, and this is going to be like this. In other distance between two similar points. So when you look at from here to here, what is the distance? 720. Or from this point to this point. The period is 720. If you start from here, then this is the similar point. So then this distance is still 720. So period is 720. Next one is y equal half cos theta. This one is y equal cos theta. And y equal cos theta. Then y equal minus cos theta has to be go opposite. So like this. So this is y equal minus cos theta. Now I want to make half y equal minus half cos theta. It means I need to squeeze this graph like this. So this is minus 1 plus 1. This is so then this is plus half, this is minus half. Then the graph is going like this. Like this. So this is y equal minus half cos theta. Uh, period is 360. Y equal tan theta minus 90, and part C, and theta minus 90 equals 0, theta equal 90. You have to shift this graph 90 degrees to right, 90 units to right. It's meaning the tan graph, the asymptote is going to be at 90. So this is 90 asymptote. Now shift this one 90 degrees. Then when you shift this one, this value become 180. Or I'll keep this one, this is 90, and this asymptote become 180 become the asymptote 90. Let's go through 90 like this. So this is for tan theta minus 90, and this is tan theta. Now tan same AB curve here for tan theta, now it is here shifted 90. So this is 0, this is 90, and this is 180. Now this D line is now here, but the value is 180. So now period is going to be 180. If we pick up this point to similar point, the distance. Y equal tan theta graph, the asymptotic as 90. When theta equal 90, tan 90. But here tan 90 you will get when theta equal 45. When you submit tan 2 times 45, 90. You don't need to wait to go up to 90. The asymptotic you will get at 45. Because when you put 45, tan 2 theta make 90. Now this is the difference. In tan 2 theta, you will meet the first asymptote at 45. But in tan theta, you will meet the first asymptote when you go from 0 at 90. You will get this kind of graph. When you realize 0, the curve go through 0 and 90, and then you can mark 90, 180, 270, minus 90. The curve is going through, and in between 0 and 90, the middle line is going to be the asymptote. That's how you want to look at to draw easily. And here the period is 90. Question number 6. 1a, we want to show that cos theta equal cos minus theta. When you draw y equal cos theta curve and y equal minus cos theta, the both curves are same. And y equal cos minus theta is a reflection of y equal cos theta. You can clearly see that when you draw y equal cos theta, and y equal minus cos theta, the both graph is going to be the same graph. Then, hence your conclusion is cos theta equal cos minus theta. In other way, cos I will write like this: cos minus theta is cos theta. So what is the use of this one? If you see cos minus 40, theta has to be acute angle. Uh, if you see cos minus 40, you can simply write cos 40. So this is the use of it. Number 2, we want to show that sine theta equal minus sine minus theta. Basically, sine theta and this one are both same. If you draw y equal sine theta and y equal minus sine minus theta, they are going to be the same. Okay, assume that this is y equal sine theta. 90, 180, 90, 180, 270, 360. So this is sine theta. Then we'll draw sine minus theta. It means this is a reflection of sine theta graph. So in that case, this is going to be minus 90, 180, 270, 360. So if you keep a mirror, you can see this part like this, and like this, and like this. So now this is the mirror reflection of sine. This is sine theta. This is sine minus theta. Now what will happen? Minus sine minus theta. Now this is minus. I will take the minus value of this one. It means this is going to be reflection of x-axis. Now this part is going to be a reflection of x-axis. It means if you keep a mirror here, you can see this part is going to be like this. Then you can see this part is going to be like this. And when you continue, what is this curve? Sine curve. This curve is going to be sine curve. Hence sine theta equal minus sine minus theta. Now, how about this one? If I take theta equal minus alpha. Now, if I apply theta equal minus alpha, what will happen? This is going to be minus sine minus alpha equal minus sine minus alpha. Right? Sine minus alpha equal minus sine minus become alpha. So if this is alpha and this is alpha, can I write in theta? Sine minus theta equal what? Minus sine theta. Actually, we made this equation earlier. So the other one is sine theta equal, both same in other way, sine minus theta. Same as sine theta minus 90 equal minus cos theta. So basically, uh, what is the meaning of that? When you have a sine theta, then you shift to 90 degrees this sine theta, then that one is equal to, you have to cos theta and reflection of x-axis. So both are going to be same. Now you can see this is sine theta graph 90, and I shift this one by 90 degrees to right. Now instead of 0 here at 90. So you can get this kind of graph. This is cos theta. Now we need minus cos theta. It means I want to get the mirror reflection around x-axis. Then what will happen? This part become like this. This part become like this. And this part become like this. So this is the curve. You can see it is going to be the same curve. Same curve. Part B. Um, those are the identities we know. Cos theta equal cos minus theta, sin theta. The same thing, sin minus theta equal minus sin theta. And from the graph, you learn those all the graphs are equal. Now we want to prove this one. Sin 90 minus theta equal cos theta using this. Okay, I'll start left hand side. What is it? Sin 90 minus theta. So 990 minus theta, I will take minus out from here. Then this will become theta minus 90. When you multiply this one, you can see it's still the same thing. Now I'm going to use this one. This is same thing. Now this, if there is sine, this is also sine. So I'll write sine. Then minus symbol here, minus symbol here. Right? Then theta, this whatever it is here. Now instead of whatever it is here. Then apart from that there is a minus value. Right? So I write like this. So sine minus theta minus sine theta minus 90. Now when I look at this one, what is sine theta minus 90 is minus cos theta. So I can write minus cos theta here. Sine theta, instead of sine theta minus 90, I write minus cos theta. Right? So this minus I leave as it is. So this is the minus. Minus times minus positive. It means this is going to be cos theta equal RHS. This is very simple thing, but it's confusing. So make sure that you should do like few times to get use of these things. For example, how do you prove from here to here? I show this one. Instead of theta, if you put minus theta, okay, minus alpha, what will happen? This become minus alpha, and this is minus sine. Minus alpha become positive alpha. So what is the substitution to show this one? Theta equal minus alpha. Then you will get this one. So from here, sine minus alpha equal minus sine minus theta mean minus alpha again. So then minus sine, this is going to be minus times minus plus sine minus alpha equal minus alpha. So this is alpha, let me write in theta, so then it is, so sine minus theta equal minus sine theta. So I proved from here to here by using a simple substitution. I know this is a simple substitution, but you should have a good experience, or you have to practice. You have to apply some values and you have to practice this kind of type of sums. This is part C. So I have all the relations, and then I look at this is the one we want to prove. Then this is two type, not sine sine, no cos. This is cos and sine. So which one is now cos and sine? I can see this one. I want to make somehow cos 90 minus 30 first. So I'll write this side first. Minus cos 30 equal, this is sine theta minus 90. I change the side. Now I can see instead of theta, now what you can tell? You can see 90 minus theta. So I am writing instead of theta now 90 minus theta. Now sine, instead of theta, what I am going to write now? 90 minus theta and minus 90. Then this is cancelled out. This is going to be minus sine theta equal minus cos 90 minus theta. Now one part is done now. I need sine minus theta to become sine theta. So I know from here sine minus theta equal minus sine theta. So then instead of this one I can write minus sine theta minus cos 90 minus theta. Now I can see both side minus. When I multiply by minus, it will cancel out. Then the final answer is cos 90 minus theta equals sine theta. In here you're substituting instead of theta, you are writing 90 minus theta for this one. Let me write this is 1. So this is from 1. Question number 7. Y equal cos x plus 30. It means the cos graph x plus 30 equals 0, x equal minus 30. You want to shift 30 to the left. In the cos graph, cos x graph, so it is crossing this point at 90. Now when you shift, what is the point? You are shifting 30. Then the graph is going from where? 60. So the first crossing point, positive crossing point, this one is instead of 90, 60. Likewise, you are shifting everything by 30 to the left. Now, in the cos graph, first point is 90, and the second crossing point is 270. What is the difference between 180? It means from here also on the next one you will get 60. Other one is 60 plus 180, which is 240. The other one is you will get 240 plus 180, which is 420. I think it is out of, and the same way. So 60 minus, so this is 60. 60 minus 180, this is 120. 120, 120 minus 180 minus 300. So the coordinate is going to be minus 300, 0, minus 100, 0, and 60, 0, and 240, 0. Now we need to find the part B. The curve crosses the y-axis. Assume this one. This is a line. Y equal x plus 4. How do you find the curve this crossing place? We know this is 4. Somehow when you put x value is 0, you will get 4. So the same thing, y equal cos x plus theta curve, right? And something like this. And when this is y and this is x, when x equals 0, y-axis mean x equals 0, then y equal cos 0 plus 30. Y equal cos 30. Cos 30 means square root 3 over 2. So the coordinate of this one is 0 square root 3 over 2. So you can check from the calculator as well what is cos 30. Square root 3 over 2. Y equal sin x plus k. In your graph you can see that this one crosses at 120, not 180. It is crosses at somewhere here 120. It means it was shifted to 180 minus 120, 60. 6 to the left. So then y equals sine x plus 60. Or the same point you can take by shifting to right 300 hours. So this is 60, shifting the other way around. So 300 minus 60 equal 300. If you shift to left to 60 or sine x minus 300. If you shift this sine curve to 300 to right, still you get the same. Question number 9. The rock pool can be modeled by sine 30 times t. It means x-axis is t, the y-axis is y, which is sine 30 t. Now sketch the given interval. So what is the given interval? 0 greater than t greater than 6, including 0 t 6. So okay, 0, 1, 2, 3, 4, 5, 6. Now this is t and this is sine 30t. So now sine 30 times 0, right? Sine 0 is 0. 1 is 0, 0 point. Now t equal 1. So sine 30 times 1, which is sine 30, which is half. So 1 and half, another one. Then sine 30 times t is 2. Sine 60. Sine 60 means square root 3 over 2. Then square 2 square root 3 over 2. Now this one. Sine 30 times 3. Sine 90. We know sine 90 is 1. So that when t equal 3, we will get the maximum. Sine curve vary between minus 1 and 1. And then sine 30 times 4, sine 120. Again, it is going to be square root 3 over 2. And sine 30 times 5, which is sine 150. So this is square root 3 over 2. Sine 150 is half. So this is 5 and half. And sine 30 times 6, sine 180, which is again 0, 6, 0. So we have the coordinate to draw the graph. So this is t 0, 1, 2, 3, 4, 5, 6. And maximum value is 1. So 1 is at here. When x equals 0, 0 and 6, 0. So those are two roots of this one. So it's going to be something like this. Part B, if t equals 0 represent the midday, during what time will be the rock pool be at least half full? So this is plus 1 for full. So half full mean half. So it means half will give which figure? Okay, this half I can see when half, this value is half, the t value is 1. So it is going to be 1 half. What else I can see the half? Okay, here 5. that is also half. So 1 to 5, it is more than half, and less than 1, up to 1 it is less than half, and after 5 it is less than half. So the answer should be between 1 p.m. to 5 p.m.